Hey team, so example C, we're going to actually predict the products. And you do actually have the skills to do this. It's kind of exciting. So I look at NH3 and H2SO4. All right, so this is actually the reason I teach you the Arrhenius definition, because it'll help you figure out what's going to happen. So NH3 and H2SO4, which one has a hydrogen it can give away? Now, you probably look at this and you're like, well, NH3 has hydrogen and H2SO4 has hydrogen. Which has hydrogen in the front? H2SO4. Very nice. So, this will act like our acid. The hydrogen at the end, not gonna be very common in an acid. There's one example I can think of, acetic acid, but I'll show you that another day. All right, so H2SO4 is going to lose a hydrogen. So now it's HSO4, and when it loses the H plus, right, it's going to be negative by 1. So you get HSO4, and that will be your conjugate base, right? Because if it goes backwards, it'll gain that hydrogen back. And then the NH3, and you've actually seen ammonia in some examples before, NH3 can accept a hydrogen. So it will act like the base, and it will turn into the ammonium ion, right? Because NH3 turns into NH4, and it gained an H plus. So it's not just an extra hydrogen, it's also that positive. And what it turns into, think opposites. The conjugate base makes a conjugate acid. And think about it. If this reaction goes in reverse, the NH4 becomes NH3. It loses or gives away a hydrogen.